Hello, welcome. In this video, we're going to learn how to compute the Spearman's rho and its 95% confidence interval using R. First, I want to load in the dataset, the Aries dataset, in the R package datasets. So you see a little bit about the information about the dataset. And in order to compute the Spearman's rho, we can use the R function called the core.test. Let me show you. First, we just assign the sepal.length to x and the sepal.width to y. And we can call the function core.test. And remember, you need to specify method equal to Spearman. Otherwise, by default, it will compute the Pearson's correlation. Okay, so it gave us a warning message. So it says cannot compute the exact p-value with ties. This is just something. Sometimes it happens with ties when you use a non-parametric method, but it is not an error message. So the computation still went using the approximation method. So here the p-value is 0.4. So if we use the 0.05 as the level of significance, so we can conclude there is a correlation, non-zero correlation between the length and the width for the species. The correlation itself is, let's see here. It's a negative 0.16. So it's not quite big, but it's okay. If you want, like, really formally perform the hypothesis test, you can rerun it. You can use the alternative to two-sided. Of course, you can specify as alternative to one-sided. You can read the help file for this function and figure out the details. Let me just go ahead and do the test. You can see the output from this hypothesis test. It's a long list. Has a lot of attributes to it. But then you noticed it's really let's first get the estimate. Oh, yeah. We can get the estimate for the Spearman's rho. So it's a negative 0.16. And then for computing a confidence interval for the Spearman's rho, it's a bit more complicated. And we need to use Fisher's Z transformation. Okay, so basically we transform the original data into a new scale which is closer to the normal distribution. So let's do that. Fisher's Z transformation. And we need to calculate standard error and then the margin of error. And then we can calculate the confidence interval. Lower bound, upper bound. And then we store the lower bound and upper bound into this object, confidence interval rho. And it is a negative 0.31 and to negative 0.006. All right. And if the sample size is rather small, you probably want to use the bootstrap method to compute the confidence interval for the surveillance rule. Okay, that's all. Thanks for watching.